Hello everyone, I'm Paul and today we're solving problem 1922, count good numbers. So we're given an input, let's say n equal 2, and this means that we are analyzing every number which has 2 digits. This means we are analyzing every number from 10 to 99. Okay. Now let's say we are at number 23. Here at index 0 we have a 2 and at index 1 we have the 3. So index 0 is an even index. So if in any even index we have an even value, we are good to go. And if we have a prime number such as 3 at an odd index such as 1, we are also good to go. So in this case we can count the number 23 in our result. So we would add 1 to our result. Okay, now let's say n is equal to 1. Well, we're analyzing every number from 0 to 9 in this case, and given that n is equal to 1, we are analyzing only one index, which is even. So basically we need to know how many even numbers do we have from 0 to 9, and the answer is 5. Numbers are 0, 2, 4, 6 and 8. So with this in mind, we can say that from 0 to 9 we have 5 numbers, and we have 4 prime numbers from 0 to 9. These numbers are 2, 3, 5 and 7. So what this means is the following. Let's say again n is equal to 2. This means we have 2 indexes, 0 and 1, and for index 0 we have 5 possibilities because index 0 is even. So given that we have 5 even numbers, here we have 5 possibilities, and for index 1 we have 4 possibilities because we have 4 primes from 0 to 9. So for this digit at index 1 we could place any of our 4 primes. So here we can put a 4. And to get the result we only have to multiply these values. So 5 times 4 is 20. What this means is that in every number from 10 to 99, which are all the 2-digit numbers, we have 20 numbers that meet these problem requirements. Now let's say n is equal to some even number such as 4, and this means that we have to do 5 times 4 times 5 times 4. Okay, so this is our answer. And do you see a pattern here? We have 2 even indexes because this is index 0, 1, 2 and 3. This index is even, this is even, this one is odd and this is odd. So we have 2 odds and 2 even indexes. So this is the same as saying 5 square times 4 square, and this is 400. Okay, now let's say we have some odd number in n. Let's say n is 7. In this case our formula would be 5 times 4 times 5 times 4 times 5, 3, 4, 5 times 4 times 5. This is the same as saying 5 to the power of 4 times 4 to the power of 3, 4 cubed. So here we have 4 even indexes and 3 odd indexes. What this means is whenever we have an odd number at n, we need to add one to our even indexes count. Okay, the time complexity for this one will be of 1, and space complexity is also of 1. And now we'll go with the code, and hopefully you will get the idea. First we'll have our mod value here, 10 to the 9 plus 7. And now we will split n. So we'll have n divided by 2, n divided by 2 odd numbers, and n divided by 2 even numbers. So odd numbers will be n divided by 2, and even numbers n divided by 2. And we want to run down our odd values, our odd numbers, and round up our even numbers. So we always make sure that the even numbers are greater than the odd numbers when we have an odd input. So here we can say n plus 1, and finally we need to return our small formula, which is in Python you can write it like this: 5 to the power of our even numbers modded times power for our odd numbers modded, and we want to mod this one more time, and yeah, that's it. So this should be the final answer. Let's see if we get an error. And this works. So if you found this useful, please drop a like and subscribe, and see you next time. Bye bye.